everyone. Welcome back to Math SAT. No, SAT. I always get it confused. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and his brother Joel Chaiken. We're here to help you understand how to approach SAT math questions. So here we are, question 30. It is in a calculator section of an older test, an older practice test. But post 216. Okay.
Yeah.
The figure above shows a regular hexagon with sides length A. So, I can't resist. I got to put the A in there and tick marks to say they're all the same.
Yeah.
Oh, and look at this. This is also A. Oh, my God. Look at that. Everybody's an A because, you see, the square is sitting on the thing.
Yeah.
Okay. Yeah. You have to go, Seth?
Yeah. Right. They're all equal.
Okay. If the area of the hexagon is 384 radical 3 square inches, what is the area in square inches of the square? So this is geometry. So the area, let's do it backwards. The area of the square is A squared, right?
Yeah.
So if we know A, then we are done with the problem. For all practical purposes, we're done with the problem. So now it comes down to what is A. So now it comes down to, given the area of a hexagon,
okay,
what is the side of a hexagon? Right? Given the area of a hexagon, so it would be really nice if we had the formula for the area of a hexagon. I don't think they give it to you on the SAT.
No. But here we go. I would approach it like this.
Okay, how would you do it?
A familiar figure in geometry is the equilateral triangle.
Definitely. Absolutely.
And the hexagon is composed of 6 equilateral triangles. They may well give us the formula for the area of an equilateral triangle as a function of the length of the side.
I don't think they do. Well, first, how do you know?
They'll have to figure it out.
How did you know that this was equal to this? How did you know that?
Well, it's all the angles are 60 degrees.
Oh, yeah.
It's just familiarity with hexagons. All the angles are 60 degrees.
Right.
If it's a regular polygon, then all the triangles defined by the center and the side are congruent.
Right.
Since it's a hex, there are 6 of these triangles. It's 360 degrees of the circle, so each angle is 60 degrees.
Right.
I know that, again, a familiarity with hexagons, you could derive from the sum of the interior angles. That the interior angle of the hexagon is 120 degrees.
Right.
That's
wait. Stop. That's the one.
Oh, yeah.
That's this one. The sum of the angles of a hex. The sum of the angles of a polygon is this, and then each one is this. So if n is 6, then this thing is equal to 120.
Yeah. So let's see if we could derive an expression for the area of a triangle.
An equilateral triangle, right?
An equilateral triangle. Well, an equilateral triangle, the way I draw it in red here. I drew, perpendicular the altitude, right?
Right.
I don't. And then, what is it? So therefore, if each side is A, then the length of this short side here, the length of this is A over 2.
Right.
Therefore, we could figure out the size of the altitude. The size of the altitude using the Pythagorean theorem. Using the Pythagorean theorem, the altitude, the hypotenuse squared, A squared equals A over 2 squared plus, let's call it altitude is L squared, right? So I could figure out L L squared is equal to A squared minus half of A squared. So that's L squared. We need the square root of it. So to get L is equal to square root of A squared minus half of A.
I'm just going to move here, little Seth. Hold on.
Right?
Yeah.
Yeah. Well, I could simplify this. Factor out an A from the square root. And we get 1 minus a half squared, which is A times the square root of 3/4.
Right.
Right? And so that is L. Remember, this is L. And the area is L times A divided by 2. The area of the triangle.
Right.
So L is A times square root of 3/4. Therefore, the area of the triangle is equal to A, right, times the square root of 3/4. Okay, that's for L, times A divided by 2, which is A squared times a half of the square root of 3/4. I don't know, should we simplify this?
What a mess. I mean, Seth.
Yeah, so the area of the triangle, the area of the square is A squared. The area of the hexagon is 6 times A squared times half of the square root of 3/4. Oh, what a mess.
Yeah.
I'm not simplifying anything.
Totally a mess.
And then if the area of the hexagon, so if this thing is equal to, it's a complicated thing, so I'm going to write it here. 6/2 A squared times the square root of 3/4. Right.
Right.
This thing equals this. What is A?
Right.
Oh no, what is A? But we want A squared.
Yeah, we want
the
A
area
squared, right.
of the square. So we could, if this messy number 384 times the square root of 3 equals A squared times this constant, then A squared equals this thing. I don't want to.
Basically, you're solving for A squared. That's the bottom line.
Yeah.
So I don't know how. I bet that if I erase some of the stuff I wrote to make space for you.
Yeah. Okay, don't mess it up. Let's leave it the way it is.
No, I'm erasing my stuff.
So we solve for A squared.
Yeah, you solve for A
now
squared.
you could use the calculator now.
Wait,
or you could do it algebraically.
Yeah. No, I had to that calculator maybe. Well, the calculator. See, what happens is the radical 3's cancel. So you've got. But let's do it.
Doing it algebraically, you cancel out stuff until you're left with a simple expression for A.
Yeah. But I think you went. I'm a big fan of not simplifying, but I think you went a little overboard here, because this is really 3A squared radical 3/2. That looks a lot nicer than what you wrote. You went a little overboard.
Sure,
you went a little overboard on not canceling.
Really?
Well, yeah. I mean, 6/2 is 3.
So 3. Yeah, that's right.
Yeah.
Okay,
You went a little overboard. Seth went a little crazy on that. And that just equals, so you're saying that equals 384.
Yeah, so
Radical 3. Now notice conveniently that the SAT people gave you a radical 3 on both sides, so goodbye radical 3. Goodbye radical 3, see you later. So that this is simply a squared is equal to 384 times 2 divided by 3. And now the calculator comes in. Now
so it's either 256 or 192.
Right. Yeah,
and
so then your calculator
2/3. Okay, I think we have to actually calculate it.
Yeah.
Divide the 384 by 3, and we get
128.
Divide 384 by 3.
Yeah. Everyone has a calculator. Everyone has a calculator. Don't worry.
Something's wrong.
No, it's not. It's not. I did it. What's wrong is that you're not using your calculator. Just use a calculator.
No. This isn't an integer.
It is. 384 divided by 3 is 128.
It is?
Yeah. You're wasting everyone's time. You're wasting everyone's time. Just use a calculator at this point. Just use a calculator.
I'm sorry. All right. So
yeah.
3. Let's see. 3 is 2, 24.
Yeah, it's
all right.
true.
So
it's true. Yeah.
It's 128 times 2, which is 256.
Yeah,
right.
256.
Okay.
Yeah. So that's great. That's great. Yeah. So Seth, you did something incredibly clever in that you never actually had to get A. You realized that the answer was A squared. So you kept the A squared and you never actually solved for A.
That's right.
Which was really, 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 really clever. This is a mess. I don't think anyone would do it that way. I don't think anyone would do it that way. I think there are two ways people would do it. People would do it this way, but immediately, as soon as you see this, they would do A squared minus A over 2 squared, and you would see it's 3/4 A squared. Right?
Yeah.
You would never leave. Most people would never factor out the A. That's like a PhD way of doing it.
Yeah, well, that's what I get. That's what I got.
So most people would get it would simplify this as 3/4 A squared. It's 1 minus a quarter because 1/2 squared is a quarter. And then we'd write it as 3/4 A squared, which is sort of like So it's like that's the way most people would do it.
I don't know about most people. I have to take a survey to answer that way. It's just very tempting. It's just very tempting when you see a square factor under square root to factor it out. Of course,
yeah.
In some situations, you must be concerned that there are two ways of factoring it out. One is to factor it out as minus A.
Oh, forget it. It's geometry.
But here everything's positive, so we don't worry about that.
Now, virtually everyone who was taking the SAT in 10th grade math, whenever they took 10th grade math, geometry, had this problem somewhere in classwork.
Yeah.
We have an equilateral triangle, and you have to figure out the area of the equilateral triangle using the 30, 60, 90 relations. But guess what? Many of the people learn it by memorizing the relationship of a 30, 60, 90 triangle. We never learned that stuff. I don't know. Do you know what I'm talking about? Do you know what I'm talking about? Maybe not. No, okay, fine. Let me tell you how many people are currently learning how to solve the area of a triangle if it's a 30, 60, 90. The Pythagorean theorem is great because you don't have to memorize anything. You apply the Pythagorean theorem. But I guess we have to move to the side here. Actually, now, the way a lot of people are learning it is you get a 60, and a 30, and you have A here, and you want to get the area. Oh, the area, big A, is 1/2 A times H, the height, right?
Yeah, sure.
So you want to get the height. You know that this is
H times the height, yeah.
Right. You know that this is A over 2.
Yeah, yeah.
Believe it or not, many people, the way geometry is taught now is they're taught that you are given, if you have a 30, 60, 90 triangle, you're given a ratio of 1 No, what is it? What is it? What is it? It's 2, 1, and radical 3.
Right.
And this
Yeah.
is what
Yeah.
you're taught. And then you have to apply this to get the
Yeah.
height. And then when you do that, it gets a little confusing because many people are really good at that. I certainly am not.
Okay.
It's not that obvious. I guess, look, you change this to
Yeah.
Yeah, you know what I mean?
Right. So, that the height, the long side is the square root of 3 times the short side. Right.
Right.
Okay.
Yeah. Oh, I see. So that means that
the
this
height
side
is the square root of 3 times a over 2.
Right. And believe it or not, you get the same answer.
Of course. Yeah.
Yeah. Right.
Yeah. I just didn't think of approaching it that way.
I would say that I don't know. We don't know whether most people taking the SAT right now in the year 2022, based on the way it's taught at school, we'll do it this way or we'll do the Pythagorean theorem. I love the Pythagorean theorem way because you don't have to memorize this. This requires some memorization. Yeah.
No, I think in the days when I took the SAT, I was closer to having been taught this, and what I might have applied this method. I might have remembered better.
Yeah.
About the ratio 1 to square to 3 to 2.
Right. Now, Seth was very clever.
But the thing is, what I used to remember, which I feel uncomfortable, is I think of it more in terms of the hypotenuse being 1, then the short side is a half.
Right.
And the long side is the square root of 3 over 2.
Yeah.
So there's more numbers floating around.
I know. There's a danger with this. Again, it's memorization. What I like to, if I have something like this, very often I do similar triangles. I would say that, H, the height. Okay, let me see how. I can't resist showing similar triangles because this is a nice way of doing it without waving your hands. Because you sort of waved your hands and said, "Oh, H is radical 3 times this side." But if you do similar triangles, it's H over radical 3. Right? These two guys are similar. Compared to equals A over 2 over 1. These guys. Okay. And then you solve H, and H you see H is A over 2 radical 3. And then you don't have to wave your hands. Then you're doing something you really should know how to do, which are similar triangles.
I don't think I was waving my hands. I saw that the ratio of the short side to the long side is that the long side is the square root of 3 times the short side. Because the short side is 1.
Right, yeah.
To get to the square root of 3, you multiply by square root of 3.
I know, but it takes a little bit of insight. It takes a little bit of insight.
A little bit of insight about what proportions mean goes a long way.
Yeah. Seth noticed that because
similarly, I think what I remember better is that if I know the short side of a 30, 60, 90 triangle, I know right off that the hypotenuse is twice the short side.
Right.
All right.
Right. Yeah, that's the way. That's exactly right. If someone gives you a 7 here, then you immediately know this is a 14. And what? This should be 7 radical 3, right? No, 7 radical 3.
Yes, 7 radical 3.
7 radical 3, right.
Yeah.
Okay, so this is a 30, 60, 90 triangle geometry problem that you have to know how to deal with a 30, 60, 90 triangle problem, or you just use the Pythagorean theorem, like Seth did, and that plans it all out. And many people would just solve A and then square it. That's okay. You could solve A and then square it, but it's more efficient. But the critical thing, notice, is that the radical 3's cancel. See?
Yeah. Well, if here's another tip, if you sorry. Does this do a bat? Yeah, it does a bat. Yeah. If you have your 30, 60, 90 triangle. Oops.
Well, here's a 30, 60, 90 triangle. We have one
No,
line.
I want to draw a new one. 30, 60, 90
Where
triangle.
are you drawing? We don't see it.
I'm drawing it. Oh, you can't see it? All right. All right, here's your 30.
No, there it is. There's your 30, 60, 90.
Okay. There's your 30, 60, 90 triangle. And what is it? Suppose you remember this is 1.
Yeah.
And this is 2. Oh,
right.
Gosh, I forgot what that is.
Yeah,
so use the Pythagorean theorem.
Right.
The square of this, equals 2 squared plus, the square of this equals 2 squared minus 1 squared.
Right,
which is 3.
Right, exactly.
Right.
Exactly. So then then
you might, I think one might, the triangles that they ask you to memorize are the 30, 60, 90.
Yep.
And the 45, 45, 90.
Right.
And with the 45, come on, you silly thing. Yeah. With the 45 triangle, the ratios are 1, 1, and the hypotenuse has the irrational ratio to the sides.
Right.
To both sides, the square root of 2.
Right, exactly.
Right.
That's right.
Yeah.
Okay, so then that should do it. So basically you're calculating a squared. A squared is the answer, and you use geometry, 30, 60, 90 triangle or Pythagorean theorem to get that. And Seth, you also had to know, which means they want you to know the relationship of the different triangles inside a polygon. And whenever you have a geometry problem and you have to calculate the area of a polygon, you always split it up into triangles, and then you multiply by the number. You find the area of each triangle and multiply by the number of triangles.
Okay. I think I like to think in terms of the hypotenuse equaling 1.
Yeah. Right. Yeah.
Because then you could put the triangle in the unit circle.
That's right. Right.
1 is the
that's right.
is the radius of the unit circle, and then if this is the angle alpha, that's the angle. Right. Then the length of this vertical line is sine alpha.
That's right.
Right, and the length of the horizontal projection of the hypotenuse is cosine of alpha, and this works no matter what alpha is.
Right.
When you take the sine values, or the values of the trig functions, could be negative.
That's right.
And this way you can remember, it makes it really easy to see that if the angle is in the second quadrant, then the sine of the angle is positive and the cosine of the angle is negative.
Right.
If the angle is in the third quadrant, both sine and cosine are negative.
Right.
And in the fourth quadrant, cosine is positive and sine is negative.
Right. That's right.
So I draw this little circle.
Yeah.
Reminds you of those things.
At some point, I'm sure we're going to have a unit circle problem. This is not a unit circle problem. We just overkill here, as we always do.
Yeah, but if you know the trig functions and the unit circle and the Pythagorean theorem, then you could always rederive the relationships for some relationships for sines and cosines of 45 degrees and 30 degrees and 60 degrees from each other.
Right. And the reason why, just to end off, the reason why the sine and the cosine are important is because that is essentially what's going on here. That is essentially what's going on. You're essentially using the sine or the cosine, right? That's the essence, right? Because here we have a over 2, and here we have a 60-degree angle.
Yeah.
So that and now the hypotenuse is 1. The hypotenuse is a, right? So then you would say that the sine of 60 is the thing we want, h over a, and then you know what the sine of 60 is. The sine of 60 is what radical 3 over 2. Okay, so that's how sine and cosine come into the problem. We never even mentioned sine and cosine, actually.
Yeah.
Well, we did this, but Seth brought it up, so what the hell?
Yeah.
Okay, so please like us.
I hope this helped. We did a review of practically all the trigonometry you need to know for the SAT.
Right.
We went in one video.
Fast. We went a little. We went a little fast on the unit circle. We'll get back to that when it comes up. But yeah. Okay, everyone.
Well, I guess do they cover tangents? You have to know some of what the tangent is.
We'll find out when we do enough practice questions. But we also go to Queller, and no, not Queller. We go to Con and count. Eventually, we'll see in Con what people need to know.
Yeah.
Okay, everyone. Have a great day. Like us, dislike us, give us comments, and of course, send us questions if you have any SAT math questions you want us to go over at SAT Math Question of the Day. Okay, we really killed this one, plus more. Okay, everyone. Have a great day. Bye.
Bye.